Hi everybody, in this video we're going to cover section 3 of chapter 4, the slope-intercept form, y equals mx plus b. In this video we are going to recognize the slope-intercept form of a linear equation. We're going to use that form to graph the equation. We are going to write the equations of lines given their slopes and intercept, and yes, you'll never guess which form we're going to use. Given 2 points either as ordered pairs or by picking 2 points on a graph of a line, we are going to find the slope, and then we are going to find the slopes of and graph horizontal and vertical lines. So let's get started. This right here is the slope-intercept form of a line, and it is perhaps the most intuitive representation of a linear equation. For example, given this equation, I know exactly where it crosses the y-axis, right here, where B is, and I know how steep it is. The larger this number, the steeper the line. The smaller this number, the flatter the line. If this number is negative, then the line will go downhill, or at least what I like to call it downhill, and the larger the negative number, the steeper the downhill line is. Here is an example of a line of an equation in slope-intercept form. Here we have y equals 4/3 x plus 1. It crosses the y-axis at 1, and its slope is 4/3. Basically, for every change in 3 units in the x-axis, the line goes up 4 units in the y direction. 1, 2, 3, 4. Let's talk about computing the slope from 2 points. So here we have 2 points. I'm going to call one x1, y1, and I'm going to call the other one x2, y2. And then the slope is really nothing more than the ratio of the difference between the two y-coordinates, y2 minus y1, and x2 minus x1. So it is typically expressed as a fraction, sometimes as a decimal, but in this particular case it is more intuitive as a fraction, and you'll see why a bit later. So here's an example. Well, we have 2 points here, -3 and 5, and 2 and 9. Let's go ahead and call this one x1, y1, and this one x2, y2. If that is the case, then we are going to have y2 minus y1, which by the way happens to be equal to 4, divided by x2 minus x1. And 2 minus -3 is just like 2 plus 3, which would give us a 5. And that would give us a slope of 4/5. Now you might be tempted to write that as 0.2, and I would encourage you not to, because what this tells you is that for every time you move 5 units in the x direction, you want to move up 4 units in the y direction. So this would be our run, and this would be our rise. Again, this is our run, this is our rise. Okay, what about computing the slope from a graph? Well, take a look at the following graph here. Remember, the slope of the slope is the ratio of the rise, which in this case would be a negative rise. I kind of forgot the points so far, over the run, and the horizontal arrow would be the run. So let's pick 2 points. Okay, here we go. I have 1 point here, x1, y1, which is that the coordinate is 1, -1, and the other one, x2, y2, is 7, -5. If that's the case, now I can apply the slope formula. And here I will have, I'm going to call this one x1, y1, this one x2, y2, and I'm going to have y2, which is -5, minus y1, which is -1, and that basically turns into -5 plus 1. For the x variables, I have 7 minus 1, well that's just 6. -5 plus 1 is -4 over 6, which is -2/3. And notice how you're sort of going downhill on this particular line, so it makes sense that this slope would indeed be negative. Now, which points should you pick? Well, basically, you want to pick 2 points where one, maybe the math is easy, but also 2 points where it's really easy to figure out where the coordinates are. So here, if you notice, I'm actually picking points where the graph actually intersects the grid lines. But you can pick any 2 points you want, but you want to pick them in such a way that it makes your life easy. And also notice here again that the rise is negative, or we're going down, so that's actually a negative rise, which gives us this negative value, and the run here is strictly positive. Okay, some comments about the slope. Once again, if the graph is going uphill, it's a positive slope. If the graph is going downhill, it is a negative slope. If the graph is 0, or if the graph is flat or horizontal, then the slope is 0. And that segues into our next topic, which is horizontal and vertical lines. And as we've just mentioned, if the line is horizontal, then the slope is equal to 0. And the associated equation is going to be y is equal to some number. Here's a horizontal line. Y will always stay 5 no matter what the value of x is. So for every single value of x, y happens to be equal to 5. Now with vertical lines, well, here it's the line goes straight up and down. As a consequence, the slope is undefined. If we could define infinity, which we can't, we would say that the slope is equal to infinity. But since infinity is not a real number, we just simply say it's undefined. And also notice for every single value of y, the slope for every single value of y, x will always be equal to b, or in this particular case, never negative 3. So the associated equation with any vertical line is x equals to some particular number, or x equals some particular number. Okay, so now it is time for us to do some examples. And there are a fair amount of examples in this particular video because there are a fair amount of different type of problems in this particular homework. The first question is, consider the equation y equals 3x minus 1. And what they're being asked is, what are the slopes and intercepts of this particular line? This right here is the slope, and this right here is the y-coordinate of the intercept, including the minus 1. So the slope should be 3, and the y-intercept will be the coordinate 0, 1. You would just put those values in for into Hawks, and you will have answered the question. And there you go, the slope is 3 and the intercept is 1. Okay, part B. Part B is to plot the y-intercept on the graph. Or as we established before, the y-intercept is 0, minus 1. Okay, where is that? Well, that is right there. That is where the y-intercept is. So go ahead and plot that on the graph. You probably need to move your mouse and actually click that point, and it'll produce the dot for you, and then you can move on to part C. Part C is to pick some second point on the graph and then draw the graph. Well, there's a number of ways you can do this. One way is, well, how about we just go ahead and let x equal to 1? Well, if x is equal to 1, then y is going to be equal to 3 times 1, which is 3, minus 1, which is equal to 2. So you can go over here and you can plot the coordinate, and that leads to the coordinate 1, 2. So we can go ahead and plot that coordinate 1, 1, 2. And once you click on that, Hawks will draw the line for you, and then you can just go ahead and click submit. So that's one way to do it. Here's another way to do it. As I mentioned before, slope is basically the ratio of rise over run, which of course in this case we have 3. We can actually rewrite that as 3 over 1. So for every unit in the x direction we're going to go up 3 times that number of units in the y direction. So our run is going to be 1, so we can move 1 unit, and then our rise is going to be positive 3, so that means we can go up 3 units. 1, 2, 3, and we would want to put our dot there. It's kind of like what we mentioned here. Again, we have a run of 1 unit. That's a positive 1. If it was a negative 1, we'd go in the other direction. And then a rise of 3. And that produces our point. So we can use that to plot our point. By once again, well, I guess you can go up 3 and then over 1. I kind of forgot about that little detail. Put that point down, and then you can plot that point, and then once again, Hawks will connect the dots. So there's 2 ways to do this. Using rise and run, where you can do a rise of 3 and then a run of 1, or you can actually just substitute a number for x get a value for y, and then go ahead and plot that point. Okay, our second example is consider the following y-intercept and slope. We have a y-intercept of 0, 2, a slope of 3/2. And we want to write the equation of the line. That's part A. Well, remember, slope-intercept form is y is equal to mx plus b. This is m. That right there is b. So here we're going to have y is equal to 3/2 x plus 2. And we are done with this particular part of the problem. Okay, next is going to be determining the graph of the line. Now, conveniently, they will provide you with the y-intercept. It's right there. So what you will need to do now is just to determine, is just to find another point so that you can plot that line. Now notice the slope is 3/2. The rise is 3. The run is 2. As a consequence, we can start here, and we can, if the rise is 3, we can go up 3 units. 1, 2, 3. Since the run is 2, we can move to the right 2 units. 1, 2. And that should be a point on the graph. If you don't believe me, you can always put in x equals 2 to the equation we did earlier and see what you get. Okay, once we plotted that point, then Hawks will draw the line for you. So once again, we have a rise of 3 and a run of 2. And once you plot that point, there it is. Hawks will draw the line, and then you hit submit, and hopefully you'll be correct. Okay, this moves on to example 3, which is finding the slope of a line. So here we need to find the slope determined by these two pair of points, 9, 5, and 4, 1. Okay, so in this particular case, there's actually 2 ways to do this, and here's the first way. Let's suppose we just have x1 be 9, 5, and x2 be 4, 1. If that's the case, we can go ahead and apply our slope formula, which is y2 minus y1 over x2 minus x1, and we will have 1 minus 5 divided by 4 minus 9, which is negative 4 divided by negative 5, which becomes 4/5. A lot of minus signs in that one. Maybe there's a way that we can do this in such a way that we don't have to deal with so many negatives. Okay, well, what we can do is just let x1, y1 be 4, 1, and let x2, y2 be 9, 5. It doesn't matter which one we call x1, y1 and which one we call x2, y2, as long as we are consistent with what we do. Then y2 minus y1 is going to be 5 minus 1, positive 4. x2 minus x1 is going to be 9 minus 4, positive 5. No negative signs to deal, no minus signs to deal with. One less degree of complication to deal with, and we get the exact same response. So basically, 2 approaches for the exact same problem. Okay, now here we are dealing with horizontal and vertical lines, and we have the equation y equals negative 3. Now, when if the equation is y is equal to something, then the answer is always going to be, or y equal to a constant, the answer is always going to be the horizontal line. Okay? If it's a horizontal line, then the slope is 0. Of course, you're going to be asked to also plot that equation by plotting 2, or graph the equation by plotting 2 points. Now remember, for every value of x, y is going to be equal to negative 3. So pick an x, any x, doesn't matter. And then go down 3 units, make your point. There you go. Pick another x. It can be any x you want. Go down 3 units because it's negative 3, and there's your point. Once you've done that, Hawks will graph the line for you. Just like that. Okay, and our next one is going to be, yeah, you guessed it, a vertical line. Here we have x is equal to 4, and since it's x equals to some number, for any value y, x will always be 4, we have a vertical line. As a consequence, the slope will be undefined, which is what we have here. Next, we are going to need to plot the equation, graph the equation by plotting 2 points. For every single value of y, x will always be equal to 4. So pick a point on the y-axis, any point, doesn't matter, and then move positive 4 units in the x direction. 1, 2, 3, 4, plot that point. There you go. Pick another point. It can be any point. How about this point right here? Then once again, go in the positive x direction 4 units. 1, 2, 3, 4. There you go. Once you put those points down, Hawks will graph the line for you. Obviously, when I did this, I picked different points. And there you go. Okay, so that is example 4. I believe we have 2 more examples to work with, and then we will move into the Hawks interface. Okay, example 5. We need to consider the graph and these 2 points. You'll be given the graph, and you'll be given the value of these 2 points. Makes it easy for you. And now we need to find the slope. Now, there's a couple of ways that you can do this. The first way is, okay, remember, slope is equal to rise over run, right? What you can do is start here and go up. 1, 2, 3, 4. You went up 4, your rise is 4. And now we went over, and then once we do that, we can go over 1. Go over 1 unit to get to here. And so that is a run of 1. So we went up 4, 1, 2, 3, 4 to get to the right level to get to 3, 7. So our rise is 4. And we went over 1 to get to it, so our run is 1. And 4 over 1 is just simply 4. Okay? The other way is, once again, to use these 2 points. So we're going to let x1, y1 be 2/3, x2, y2 to be 2, 3, x2, y2 to be 3, 7, and then we were going to have 7 minus 3, which of course is equal to 4, and then 3 minus 2, which is equal to 1. So that's how we can find the slope there. Okay, now we need to find the y-intercept. Well, that's nothing more. That is going to be the ordered pair where the second value is the point is the value of y when it crosses the y-axis. And notice it crosses the y-axis here. Since the line is really steep, it's kind of hard to read, but that should be -1, -2, -3, -4, -5. So in this case, b is -5, and the y-intercept is going to be 0, -5, because the y-intercept is actually an ordered pair, where the second coordinate, or the y-coordinate, is where the line crosses the graph. And that's what we have here. And then finally, we need to determine the equation for the line. Okay, well, we know that the slope is 4. We know that the intercept is -5, or 0, -5. And if that's the case, then y is going to be equal to the slope, which is 4, times x, plus the y-coordinate of the y-intercept, which in this case is -5. And there's our equation. And for our last example, remember, sometimes our slopes will have fractions, and sometimes they'll be negative. So here's an example of that. Okay, so here we have what are the slope and y-intercept for this line. Well, once again, this is the slope. This is the second coordinate for the y-intercept. So the slope is going to be -4/3, and the y-intercept is going to be 0, -3. Just like that. Okay, the last part of this is going to be to graph the line. Well, remember, this line, and we're going to do that by basically plotting 2 points. Now remember, this line is going to cross the y-axis at y equals -3. So let's plot that. -1, -2, -3, it's going to be right there. All right, awesome. Now we can use our slope to figure out the next point. It's going to have a rise of -4, which means from this point we want to go down 4 units. 1, 2, 3, 4. That puts us here. Okay, and now it's going to have a run of +3. Okay, cool. 1, 2, 3. This should be our second point. So once you plot this point on here on Hawks will draw the line for you. And then once you hit submit, it should be correct. And that is all I have relative to the presentation part. What I would like to do now is just go over a couple of homework problems. Let me get my dashboard up. And here we are. We're at lesson 4.3. And I'm going to go ahead and start practice. And obviously I'm not going to do all of them, but I'm going to do the ones, I'm going to do all the different ones. Okay, so here we have it. We have the following linear equation is y equals 3x plus 2. What is the slope? Well, once again, the slope is here. That is 3. So I'm going to enter in 3. And then the y-intercept, which is actually an ordered pair, where the first coordinate is 0, but the second coordinate is going to be described right here. It's 2. So I'm going to put in the 2. And hopefully I'm right. Oh, of course I'm right. Okay, moving on. Now we need to plot the y-intercept of the graph. Now, if you don't recall what your answer was, you can click this and there's your answer. Your y-intercept is 2. So we want to go to the y-axis and go to y equals 2, which is right here, and just basically click. And there you are. You have it. We can submit our answer. It is correct, and now we can move on. And now we need to plot a second point other than the y-intercept so that we can get our graph. So there's a couple things we can do. We can substitute 1 in for x, and you'll have 3 times 1, which is 3, plus 2, which is 5. Or what we can do is, we know our y-intercept was here. We can go up 3, 1, 2, 3, and go over 1. A rise of 3 and a run of 5. Rise 3, 1, 2, 3, run 1, right there. And plot that point. And then submit our answer, and we are correct. Okay, this is the exact same type of problem, but it is fractional, so it might be worth going over this one as well. Now here, the slope is -3/2, and the second coordinate of our y-intercept is 1. So for our slope, what we can do is, the first thing we can do is get our fraction thing going. There it is. We can put a -2 in the numerator, hit tab, and then put 3 in the denominator. Over here, we can now click over to the y-intercept, and we can put in a 1 for the second coordinate. All right, we're good to go. Now we come to this part. We need to plot the y-intercept. Once again, it is 1, so I can plot right there, submit answer, and I am good. And now we can move on to the third part, which is to plot the second point. So let's go ahead and start with the previous step answers. We know that the y-intercept is equal to 1. So we're going to start here. Now the slope is -2/3, so the rise is -2, which means you want to go down 1, 2, and now the run is 3. So we want to go to the right 3 points. 1, 2, 3. So that should be the point. If you're not comfortable with that, you can always substitute 3 for x, and then the 3's cancel, and you'll have y is equal to -2 plus 1, which is -1, which would give you that point as well. Okay, and there you go. We got that one correct. Moving on. Okay, this is the second type of problem. For this one, we actually need to write in the equation, and the way you're going to do that is just come to this little field here, type in y. What is slope? Well, the slope is right here. So we can do we can create our fraction. Oh, right there. We can put in 2, go down to the denominator, put in 5, come over here, put in x, and then it's going to be plus 2. That is how that should work. Submit our answer, and there we go. Now we need to actually plot the equation. Notice they gave you the y-intercept, so all you need to do now is come up with another point. And what you can do, once again, is use the slope. This is rise. This is run. So we are going to go up 2, 1, 2, that's our rise, and then to the right, 5. 1, 2, 3, 4, 5. And let's see if I actually did that correctly. Yay me. Okay, now here is a problem where we need to determine the slope. This turns out to be a job for OneNote. So what we have over here is we have two points. One is -1, comma 1. The other one is -4, comma 8. So I'm going to call this one x2, y2, and this one x1, y1. And we need to use a slope equation, which is, of course, y2 minus y1 over x2 minus x1. And that will give us 8 minus 1 divided by negative 4 minus a negative 1. Okay, that's going to be 8 minus 1 is 7. Negative 4 minus negative 1 is actually negative 4 plus 1. And that should give us 7 over negative 3. But I want to write that as negative 7/3. We can't have negative signs in the denominator. So to answer that, I am going to put negative 7 on top, go down and put in 3. Let's see if I did that correctly. There you go. And that's how that problem works. Now here is an example of a horizontal or vertical line. Here we have y is equal to 3. That is the form of a horizontal line. So coming down here, we just go ahead and click horizontal. What is the slope of a horizontal line? It is 0. So we put a 0 in here, submit our answer, and we are good to go. And then we need to graph the line. Remember, by graphing 2 points. Now remember that for any value of x, y is equal to 3. So pick a number for x, go up 3, 1, 2, 3, click that point. Pick any other number for x. How about the one right next to it? Go up 3, 1, 2, 3, click that point, and then submit your answer, and you should be correct. Okay, I think this is the last type of problem that we need to talk about, but I'm not really sure. Okay, so here we have 2 different points. Negative 2, negative 6, and then we have the point B, 1 and 6. And we need to find the slope. Now, we could play the rise over run game, but this would be kind of hard because you have to count from here all the way up to there to get your rise. And then you have to count over here to get your run. So in this particular case, it might be easier to do it mathematically. So we have negative 2, comma, negative 6, and then we have 1, comma, 6. I'm going to call this x2, y2. I'm going to call this x1, y1. So we will have y2 minus y1 over x2 minus x1. That is going to be equal to 6 minus a negative 6 divided by 1 minus a negative 2. That will be 6 plus 6 over 1 plus 2, which is equal to 12, divided by 3, which is equal to 4. So in this case, the slope should be 4. Okay, moving on. Now we need to find the y-intercept. Where does this bad boy cross the y-axis? Well, it looks like it crosses the y-axis right there. I don't know if you can, hopefully you can see the mouse or the cursor, but it crosses the y-axis at y equals 2. So our answer for the y-intercept, once again, the y-intercept is a point. Therefore, it must be expressed as a ordered pair, where the x value is 0 and the y value is 2. If you don't do that, if you just put in 2, it's not going to like it. So 0, 2. Submit your answer, and there you go. Way to go, me. And I believe all the other problems are pretty much the same. Or once again here, what can you tell us about this line? Well, if you actually tried to compute the slope for that line, you would get, let's go ahead and do it. Negative 4, comma, negative 7, negative 4, comma, 3, x2, y2, x1, y1. We would have y2 minus y1 would be 3 minus negative 7. x2 minus x2 minus x1 will be negative 4 minus negative 4, which will be, here we have 3 plus 7, negative 4 plus 4, which is 10 divided by 0, which is undefined. So you would go ahead and click. You couldn't put anything in here. You would need to click undefined, submit your answer, go to next, and then you're going to be asked to find the y-intercept. Now check out. Now remember, the y-intercept is that point, is that value of y where this line crosses the y-axis. There's only a slight problem with that. This line's a vertical line. It will never ever cross the y-intercept. As a consequence, your answer here is none, and you would submit your answer. And then finally, oh wait, I need to hit next first. And then finally, we need to determine the equation for the line. We'll take a look. No matter the value of y, x will always be equal to -4. So our equation is x equals -4. And lo and behold, I'm right. Hallelujah. I was kind of worried about that. So those are the types of problems we have in this section. If you have any questions, please feel free to contact me. And this is Bob Boyle, signing off.